Good day, everyone. I am Jaey Trecia of Ellorimo together with Ms. Rosana Monzales, Crystal K. Latina, Daisy Migallardo, and Mr. Rexy Jundurin, and we are the Group 9. My topic to discuss is all about the item analysis. If our students learned what we taught, we would never need to assess. It is only through assessment that we can discover whether the instructional activities in which we engage our students resulted in the intended learning. Assessment really is the bridge between teaching and learning. We can assess learners through a test, quizzes, or exam. Before we proceed to our discussion, let me present to you our learning objectives. Students are expected to develop an understanding about the concept of item analysis. Second, differentiate terms and ways on how to create and analyze students' responses on a certain standardized test. Third, distinguish concepts on how to measure an item and relate the concepts in a real-life situation of conducting a test. To understand item analysis, it can be done through first, planning of the test, which should be on designing the test and the preparation of the blueprint or the questionnaires. Then, we need to prepare for the preliminary draft, which are the item writing, editing, and the pre-tryout for learners. Then, after that, the examination proper or the conduct of the item test to learners so that we can process or measure the difficulty level and discrimination value of each item we made on the questionnaires. And that is the item analysis. After analyzing the results, we can now create or have a final draft and establishment of reliability and validity of the certain conducted tests. Item analysis is the act of analyzing student responses to individual exam questions with the intention of evaluating exam quality. It is an important tool to uphold test effectiveness and fairness. It is a statistical technique which is used for selecting and rejecting the items of the test on the basis of their difficulty value, discrimination power, and the distractors. The purpose of item analysis: first, to identify structural or content defects in the items. Second, to detect learning difficulties of the class as a whole. Third, to select the best available items for the final form of the test. Then, to identify the areas of weaknesses of students in need of remediation. Then, to increase instructors' skill in the test construction. Then, lastly, to identify specific areas of course which need greater emphasis or clarity. Therefore, item analysis is accompanied with these questions on determining learners. First, which topics are students struggling with? Second, do students really know the answer or just applying test-taking strategies to eliminate the wrong answer? Third, does the item do an excellent job on separating students who know the content from those who may merely guess the correct answer? Then, is a particular question as difficult, complex, or rigorous as you intend it to be? Then lastly, which items should be eliminated or revised before use in subsequent test administration? Basically, item analysis reveals first, items that are too easy and too difficult. Second, items that failed to show difference between skilled and unskilled examinees, or how well it discriminated between high and low scorers on the test. Lastly, items that are scored incorrectly or misgraded, rather, whether all of the alternatives functioned as intended or the distractor analysis. The benefits of item analysis: it provides useful information for class discussion of the test. Second, it provides data which helps students improve their learning. Third, it provides insight and skills that lead to preparation of better tests in the future. Item analysis do have limitations, such as it cannot be used for easy items. Second, teachers must be cautious about what damage may be due to the table of specifications when items not meeting the criteria are deleted from the test, and these items are to be rewritten or replaced. Here are the steps in item analysis, which consist of 8 steps. First, score the test. These are the scores from the conducted test. Second, arrange the test papers from highest to lowest. Third, Separate the top 27% and the bottom lower 27%. 27% is used because it has shown that this value will maximize differences in normal distributions while providing enough cases for analysis. This was based from Wiersma and Jers 1990. Then the fourth step is prepare a tally sheet. Fifth, convert the frequencies to proportion. Sixth, compute for the difficulty index. And the seventh step is the compute for the discrimination index. And lastly, decide whether to retain, revise, or reject the item. Then here is an example of scores from the conducted test. So in this example, these are the scores from a conducted test which are arranged from highest to lowest that consist of 50 items and 50 students. In this case, the 27% of 50 is equivalent to 14 students. Therefore, we should pick 14 students who got the highest scores and 14 students who got the lowest scores, and the remaining scores will remain for the evaluation. The step 4 is the tally sheet. In creating a tally, the first row should be for the headings such as the item number, the upper 27% and the lower 27% of the students, where N is the number of cases, which is the number for the 27% of the 50. So, in this table, it shows the number of correctness of the learners in each item. Let's say, in item 1, the upper and lower score of students get it correct. Then, the second item, only 13 of the upper 27% students got it correct and 11 for the lower score of students. Then, for the third item, 14 for the upper and 11 in the lower, and so on. So, after the tally sheet, we should convert the frequencies or the number of correctness into proportions. So, proportions can be solved using the formula P is equals to number of correct answers over N, or the number of cases, or the 27% students from the upper and lower scorers. So, in this table, in item 1, we have 14 students who got the item correct from the upper 27% and the lower 27%. So, proportion is equals to 14 divided by 14 is equals to 1. Therefore, our proportion in the lower and upper 27% in item 1 is 1. Then in item 2, we have 13 correct answers from the upper 27%. Therefore, 13 divided by 14 is equals to 0.93. And in lower 27%, we have 11. So, 11 divided by 14 is equals to 0.79. Then, in item 3, we have 14 correct answers in the upper 27% divided by 14 is equals to 1, therefore our proportion is 1. And in the lower 27%, we have 11 divided by 14 is equals to 0.79. And lastly, in item 4, we have 14 divided by 14 is equal to 1, and therefore our proportion is 1. And in the lower 27%, we have 7 correct answers divided by 14, therefore we have 7 divided by 14 is equals to 0.5. So, item difficulty. Is the exam question too easy or too hard? When an item is one that every student either gets wrong or correct, it decreases an exam's reliability. So, the percentage of students taking the test who answered the item correctly, the larger the percentage getting an item right, the easier the item. The higher the difficulty index, the easier the item is understood. It was based from Wood 1960. So, for example, if you have an item difficulty of 0.95, it doesn't mean it's extremely difficult. It means it's extremely easy because that 0.95 represents the fact that 95% of the students got it correct. So the difficulty index, or as the p-value, has a range of 0% to 100%, or more typically written as a proportion as 0.0 to 1.00 p-value. So the higher the value, the difficult the item. It can be interpreted using this criterion. So if the difficulty index is greater than 85%, therefore it is very easy item. And when the difficulty index is greater than 70%, it is an easy item. And when the difficulty index between 30% to 70%, therefore it is moderately difficult to moderately easy. And when the difficulty index is less than 30%, it is difficult. And when it is less than 20%, it is very difficult. Now we have the step 6, it is to compute for the difficulty index. Computing for the difficulty index can be solved using the formula DFIN is equals to P sub U plus P sub L over 2, where The DFIN stands for the difficulty index, and the P sub U is the proportion of the upper 27% who got the item correct, and the P sub L is the proportion of the lower 27% who got the item correct. So, in this table, it was based from the previous slides we solved on the frequencies and proportions of the upper and lower 27% scorers. So, in item 1, we have a proportion of 1 in the upper and lower 27% scorers. What we need to do is to substitute all the given proportion values to the given formula. So, the value of the proportion of the upper 27% is 1 and in the lower 27% is 1. Therefore, substituting those values is 1 plus 1 divided by 2 is equals to 1. Therefore, our difficulty index would be 1. And in item 2, we have a proportion of 0.93 in the upper and 0.79 in the lower. Adding it divided by 2, we have a difficulty index of 0.86. And in the item 3, we have 1 added by 0.79 divided by 2 is equals to 0.90. And in item 3, we have 1 plus 0.5 divided by 2 is equals to 0.75. Note that in computing for the difficulty index, what we only need to do is to substitute all the given proportion values in each item to the formula. So, next is the interpretation. From the previous slides, we solved about the difficulty index. And then, in item 1, we computed that the difficulty index in 1, therefore, it lies on the 0.91 above, therefore, it is very easy. And in item 2, we have 0.86. 0.86 lies on 0.76 to 0.90, therefore it is easy. And in item 3, we have 0.90, therefore it is also easy. And in item 4, we have 0.75, it is an average item. Next is the item discrimination. Thus, the exam question discriminate between students who understand the material and those who do not. Exam questions should suss out the varying degrees of knowledge students have on the material, reflected by the percentage correct on exam questions. So the interpretation of discrimination index may vary based on this range given in this figure below. Hence, the main purpose of discrimination index is to describe the ability of an item to distinguish between high and low scores, such as the scores of the upper and lower 27% of students after being ordered in descending way. So, the range of the discrimination index is from 0.0 to 1.00. The higher the value, the more discriminating the item. So, it is said that a highly discriminating item indicates that the students who had high test scores got the item correct, whereas students who had low test scores got the item incorrect. Item with discriminating values near or less than 0 should be removed from the test. This indicates that students who overall did poorly on the test did better on that item than students who overall did well. So the item may be confusing for your better scoring students in some way. 0.40 to higher is a very good discrimination, and 0.30 to 0.39 is a reasonably good discrimination but possibly subject to improve. 0.20 to 0.29 is a marginal or unacceptable discrimination which is subject to improve, and 0.00 to 0.19 is poor discrimination. This is to be rejected or improved by revision. So this is a negative discrimination index to be rejected. Next is the step 7. It is to compute for the discrimination index. Computing for the discrimination index can be solved using the formula DSIN is equal to the P sub U minus P sub L, where DSIN stands for the discrimination index and the P sub U stands for the proportion of the upper 27% who got the item correct, and the P sub L is the proportion of the lower 27% who got the item correct. So, in this table, from the previous slides of proportions and frequencies in the upper 27% and in the lower 27%, we need to substitute those proportion data or values to the formula of the discrimination index, such as in item 1, we have a proportion the upper and lower 27% as 1, therefore, P sub U minus P sub 1 is 1 minus 1 is equals to 0. Therefore, our discrimination index in item 1 is 0. So, in item 2, we have a proportion in the upper 27% as 0.93 and in the proportion of the lower 27% is 0.79. Therefore, substituting it to the formula, we have 0.93 minus 0.79 is 0.14. Same as in item 3, we have a proportion in the upper 27% as 1 minus to the proportion of the lower 27% as 0.79. Therefore, our discrimination index in item 3 is 0.21 and so on in item 4. So here comes the interpretation. As I have said earlier, the range is from 0.0 to 1.00. So the higher the value, the more discriminating the item. So from the table, we have this discrimination index in the item 1, we have 0. Therefore, it is low. Then in item 2, we have a discrimination index of 0.14. Therefore, it is also low. And in item 3, we have a discrimination index of 0.21. Therefore, it lies on the moderate section. And in item 4, we have 0.5. Since 0.5 lies on the 0.41 in above section, therefore it is high discrimination value or high discrimination index value. Note that in assessing our future students, we need to use items that have high DI values or high discrimination index values in the test. Those are the testing's higher cognitive thinking abilities such as the comprehension, application, and problem solving. So, here comes the step 8. Decide whether to retain, revise, or to reject the item. So, when an item meets the general acceptability guidelines for difficult and discrimination, you should keep the item. If it falls outside the guidelines, you make a judgment whether to keep, revise, or reject it. So, it was stated earlier the different criterion of the difficulty index, the discrimination index, and here comes the decision making. So, when the difficulty index is moderate and the discrimination index is high and moderate, we need to retain the item. And when the difficulty index is moderate and the discrimination is low, we need to revise the item. And when it is very easy, difficult, and very difficult, in the difficulty index and in the discrimination index, it is high and moderate, we also need to revise the item. And lastly, if the difficulty index is easy, difficult, and very difficult, whereas the discrimination index is also low, we need to reject the item. Now we have the table based from our examples of the 50 scores that we solved in the previous slides. And now we have the value of the difficulty index and the discrimination index with the verdict. What we need to do here is to decide whether an item is to keep, revise, or to reject it. So in item 1, we have a difficulty index of 1 and a verdict of very easy, and in the discrimination index, we have a 0 which is low. Therefore, our decision would be to reject the item 1. And in item 2, we have a difficulty index of 0.86 and it is easy. And in the discrimination index, we have a value of 0.14. Since it is easy and low, this item would also be rejected. And in item 3, we have a difficulty index value of 0.90 and a verdict of easy. And in the discrimination index, we have a value of 0.29, which is moderate. Therefore, this item should only be revised. And in item 4, we have a difficulty index value of 0.75 and a verdict of an average. And in a discrimination index, we have a value of 0.5 and a verdict of high. Therefore, this item would be retained. Then, next is the point by serial correlation. So, point by serial correlation is used to correlate item scores with the score of the whole test. So, a special case of the person-product moment correlation where one variable is binary. So, there is a right versus wrong and the other is continuous or the total row test score. So, it can be done through steps. First, step 1 is to score the item as either right or wrong. And then step 2 is the use of point by serial correlation. Step 3 is the interpretation. And here comes the formula in finding the point by serial correlation. Where the x sub 1 bar is the main row score of all students who got the item right, and the x sub 0 bar is the main row score of all students who got the item right, and the S sub x is a standard deviation of the row scores, and P is a proportion of students who got the right answer. For example, in this table, we have the item 1, 2, and 3 with 5 students, namely Anna, Chris, Hazel, Ben, Faith. So, note that the plus or the positive symbol means correct and the negative or the minus sign means incorrect. So computing for this point by serial correlation based on this table, we have simple formula as S is equals to R sub A minus R sub B over T, where R sub E is the number of pupils who got the item right after instruction and the R sub B is equals to the number of pupils who got the item right before instruction. Then the T stands for the number of pupils who tried the item both. So note that the ideal value of S is 1 and the effective item fall between 0 to 1. Then the higher the positive value, the more sensitive the item is to instructional effect. Then items with 0 and negative values do not reflect the intended effects of instruction. So in this table, in item 1, we have a total correct after instruction is 5 and a total correct number before instruction is 0 based from the formula of S is equals to R sub A minus R sub B over T. We need only to substitute those given values as 5 minus 0 over 5 is equals to 1. Therefore, our teaching instruction is effective for item 1. And in item 2, we have 5 students who got a correct answers after instruction and 2 students before instruction. Therefore, substituting those values on the formula S equals to R sub A minus R sub B over T is equals to 5 minus 2 over 5 is equals to 0.6. Therefore, teaching instruction is effective for item 2. And in item 3, we have after instruction, we got 2 students who got correct and before instruction, we have 2 students correct. Therefore, based from the formula, we have R sub A as 2 and R sub B is 2. 2 minus 2 is 0 over 5. Therefore, our teaching instruction is not effective for item 3. This only entails how effective your strategy in teaching to students. Hence, it connotes the idea that those items or those questions we made in each item need a remediation or in need to tackled again. And now we have the item distractors. For multiple choice exams, distractors play a significant role. Though exam questions effectively distract test takers from the correct answer, so for example, if a multiple choice question has 4 possible answers, or 2 of the answers obviously incorrect, thereby rendering the question with a 50-50% chance of correct response when distractors are ineffective and obviously incorrect, as opposed to being more disguised, then they become ineffective in assessing student knowledge. The distractors are important components of an item, as they show a relationship between the total test score and the distractor chosen by the student. Distractor efficiency is one such tool that tells whether the item was well constructed or failed to perform its purpose. So, here are the purpose of distractor analysis. First, it allows us to examine how many students in the upper group and the lower group selected each option in a multiple choice item. Second, we expect distractors to be selected by more students in the lower group than students in the upper group. And lastly, an effective distractor must be selected by some students. So note that any distractor that has been selected by less than 5% of the students is considered to be a non-functional distractor. So, for example, take the correct answer in this question. When the sum of the measures of 2 angles is 90 degrees, the angles are called A. Complementary angles, B. Adjacent angles, C. Line pair, and D. Supplementary angles. So suppose we have 110 students appeared in this achievement test. Then the first, we arrange the obtained scores of 110 students in descending order. And now, we have to select highest scorer on the upper 27% students and in the lower scorer 27% students, which is 30 students for item analysis based on the 27% of the 110 students. Note that any distractor that has been selected by less than 5% of the students is considered to be a non-functional distractor. So, reviewing the options can reveal potential errors of judgment and inadequate performance of distractors. So, these 4 distractors can be revised, replaced, or removed. So, in this table, based on the question or the item 1, we have here an options of A, B, C, and D. So, in the first row, we have the number in the upper group, Second is in the number of the lower group, and then the total of both students who answered from the upper group and in the lower group, then the percentage of selection, and in the discrimination index. So, in option A, which is the correct answer, we have a total of students who chooses option A in the upper group as 22, and in the lower group we have 9. So, in the total of 31, and then the percentage of selection among 60 students is 52%, and the discrimination index is 0.43. So, in option B, we have 3 in the upper group and 7 in the lower group, a total of 10, and the percentage of selection among 60 students 16.5%, and the discrimination index is negative 0.13. So in option C, we have 2 in the upper group, 8 in the lower group, and a total of 10, and the percentage of selection or the difficulty index is 16.5%. The discrimination index is negative 0.2. And lastly, in the option D, we have 3 in the upper group and 6 in the lower group, a total of 9%, and the percentage of selection is 15%, and the discrimination index is negative 0.1. Now, comparing it with the table, we can conclude that item number 1 is moderate and very good item. Hence, we can select it. It was based from the indices of difficulty and discrimination by Hopkins and Antis. And therefore, we can conclude that option A, or the correct answer A, has a moderate difficulty index and a very good item since it lies on the 0.30 to 0.70 indices, which is the discrimination index is 0.43. So, all the other destructors from BCD are selected by more than 5% of the students, so obviously, destructors BCD can be considered as a fully functional destructors. So, here is the second example. What is the supplementary of an angle measuring 54 degree? So, choices is A, 36 degree, B, 126 degree, and C is 156 degree, and lastly D, we have 46 degree. And in item 2, we have also an options A, B, C, and D. First row is in the upper group, and the second row is the lower group, and the total number of students, and the percentage of selection, then lastly the discrimination index. So in option A, in the upper group, only 11 students who chose option A. And in the lower group, there are only 5, a total of 16, and the percentage of selection among 60 students is 26.5%, and the discrimination index is 0.2. So in option B, which is the correct answer, we have 28 students who chooses option B in the upper group and 12 students who chooses in the lower group, and a total of 40. So the percentage of selection is 67%, and the discrimination index is 0.53. Option C, we have 0 or none value because none of the upper group and in the lower group chooses option C. And in the option D, we have 0 in the upper group and 4 in the lower group, a total of 4, and the percentage of selection is 6.5%, and the discrimination index is the negative 0.13. So, the destructors A and D are selected by more than 5% of the students, but the destructor C is selected by 0% students. So, obviously, destructors A and D can be considered as a fully functional destructor. So, but C is a non-functional destructor since it values 0. So, rather, it does not have a value. So, the item number 2 is very good item, but C is a poor destructor. So, we have to revise or replace the destructor to maintain the quality of the item. So next is, let me share to you how to compute item analysis through Microsoft Excel. So first, what we only need to do is to put in all the given data's values, the number of students we need to compute, and the choices or the options we have. But most importantly, are the scores of those students. So we have here the UG as the upper group, LG as the lower group, RU as the right group, and RL as the right lower, and the NG is the number of the pupils in each group. We also need to put in the item card or the option in the UG and the LG, the option A, B, C, D. Note that in the step 2 in item analysis, we need to arrange all the scores in an ascending order or from the highest to lowest. So first, we need to select the score and answer cells, then click sort from the highest to lowest option. So this is a sample one which is an example of the number of pupils, the score, and an answer result of an item 1 taken by 50 students of grade 7 pupils in mathematics test subject for item analysis. This is the same example we had tackled using the hand-by-hand item analysis. So, first, in item 1, we have a correct answer, which is the letter C. The options are colored differently. Therefore, our item card in the upper and lower group, we have option A, only 7 students who chooses option A in the upper group and 4 in the lower group. And in the option B, 1 in the upper group and 2 in the lower group. And in option C, we have 3 in the upper group and 7 in the lower group. And in the option D, we have 3 in the upper group and 1 in the lower group. So the total number of scorers in the upper group is 14 and in the lower group is 14 since it is our number cases or the 27% of 50 students. Then next is to compute for the difficulty index or the index of difficulty. Formula in finding the item analysis in the index of difficulty in the hand-by-hand system is the P sub U plus P sub L over 2. Hence, through Excel, we can use it by the summation of x over n or the average of those students who choose option C. Summation of x is equal to sum of RU and RL, and the n is the number of both UG and LG. So we can solve the index of difficulty through this formula. So what we only need to do is to select those cells to compute the formula or type in the tab cells in the function. Here is the computed difficulty index, which is the 42.86%. So our difficulty value is 42.86%, which is acceptable based on the criterion of the index of difficulty. So now we have the discrimination index. So to compute for the discrimination index, we also use the item C. Since it is the correct answer. Then, the formula in computing for the discrimination index is the R sub U minus R sub L over NG, where the R sub U is the sum of right response of upper group and the R sub L is the sum of response of the lower group, and the NG is the number of responses discriminated. So, we have the formula R sub U minus R sub L over NG. Then, what we only need to do is also to select those cells and compute for the discrimination index. Type in through functions. So we have the value of our index of discrimination as 0.43. So our index of discrimination is 0.43. Note that when our discrimination value is positive, the upper group is a fast learner, and when it is negative, the lower group are fast learners. So, in determining the effectiveness of correct answer, or the letter C, note that it is good when more respondents from the upper group got the correct answer, and it is poor when the lower group got the correct answer. So, based from the item card we have in the option C, we have it is good because more respondents from the upper group got the correct answer. So in this, determining the effectiveness of distractors. So it is good if more respondents from the lower group got the incorrect answer, and it is poor when more respondents from the upper group got the incorrect answer. In item card, in the option C, that it is good. It is good because more respondents from the lower group got the incorrect answers than in the upper groups. And lastly, determining the effectiveness of options. In option A, it is good because lower group is greater than the upper group. And in option B, it is also good because lower group is greater than the upper group. And in option C, it is also good because upper group is greater than lower group because it is the correct answer. Hence, it is necessary that upper group should have the correct answer. And in the option D, it is poor because upper group is greater than the lower group. So, how can item analysis inform exam design? So, the data from item analysis can drive the way in which you design future tests. So, exams ought to measure the student learning gap as accurately as possible. So, note that in making a standardized test in our questionnaires as a future teacher, we need to examine each item through its difficulties, discrimination, and the distractors. So first, consider, is the item difficulty level appropriate? Second, does the item discriminate appropriately? And lastly, are the distractors effective? These three questions underlies the reliability and the validity of an item we need. If you want further knowledge about this topic, you can browse ideas through these references. So that's the end of my discussion. The next reporter will follow. Thank you.